In this video, we'll discuss the change in entropy, also known as the delta S. A change in entropy refers to an entropy state at a final state minus the entropy state of the initial state. Now, what factors cause this change in entropy? Well, there are several factors that we're going to be discussing. And the very first one is volume. Take a look at the one on the left and the one on the right. The moles of the molecules are the same for the left and the right. If you look at and say that V1 is the initial state, so this is my initial state, and V2 is my final state, as it's going from the initial to the final state, what do you think happens to the entropy? Was the entropy higher here, or is the entropy higher here? Think about it for a moment and come back. So coming back, the final state is the state in which the entropy is higher, meaning that SF, that entropy, will be higher. So there is a change in entropy, and that's due to the volume of this gas phase solution. Now, this is why. The reason why when your volume increases, the entropy also increases, as written here. This is because you increase the number of microstates. You're not only confined to, say, like this molecules in this area or this area. Now you have really expanded the area so that that particular molecule could be exist in any area within this big, large container. Now this has, again, the same number of moles, it's at same temperature. So at that point, as the volume increases, the entropy also increases. So if the entropy here, the final state has a bigger number here, so I'm going to write little big here, and then my initial is a little smaller, so I'm going to write it smaller. Then what is the sign of delta S? Well, we know that delta S, or the change in entropy, is equal to SF minus SI. Well, if this number is bigger, then this entropy S would be a positive charge. Not positive charge, sorry, positive value. Now, what other factors affect change in entropy? And that is temperature. If you increase the temperature, what happens? Even with their same amount of volume and with the same amount of moles, what happens is it will increase entropy as well. And this is because it increases the kinetic energy, which increases the number of microstates again. So in a case like this, would this entropy, change in entropy, be positive or negative? So here's my boiling water, has high kinetic energy, because the molecules are moving around so much. So you can say that this S final is quite big, and whereas ice bath, SI is small. So the change in S is SF, I'm going to write it big, minus the S little I, representing that the value of the entropy is small. So therefore, the change in X would be positive. Here's another scenario. Another scenario is when you have a number of moles in gas phase solutions increase. So here's one state and here's another state. As you guessed it, this will increase the entropy, where in which this S final is much bigger than the S initial, because you're introducing more and more molecules, letting the which allows more microstates to increase, because there are more possible number of positions these molecules could be in. So therefore, delta S again, what could delta S be? Well, since this is big and this one is small, this would be, delta S would be positive. Next scenario is to look at these phase changes. Now, before I go into which one is greater and smaller, let's just think about it for a moment of all the microstates. Microstates here, microstate in this liquid portion, and in gas. Which one do you think has more microstate? With the same amount of moles of the component, the gas phase would definitely have more microstate because they can fill up the entire volume of the container, so there's more position for them to be in. So therefore, as it goes from a solid to liquid to gas, as the kinetic energy increases, and also increases the entropy as well. So phase changes, going from solid liquid to gas, entropy increases. Now, what if the phase changes from gas and then back to liquid? Would delta H be bigger, or negative or positive? If you're going backwards, where gas is going back to liquid and liquid going back to solid, then hopefully you're able to say that delta S would be negative. So if you look at this containers, you'll notice that in the liquid, you would have some kind of entropy value as final. In comparison from the initial of the gas, this would have very high initial value, and that's because it has a number of more microstates. And so the delta H, where you have just an average entropy, and then all of a sudden you need to subtract it with the S initial, which has a bigger value, so this would become negative. And the last factor is looking at the amount of molecules formed in a chemical reaction. So say you have a chemical reaction where you have all these little particles and they form into this is kind of clumped up together into a smaller number of particles. So when that happens, we're going from this state to this, okay, you have reduced the number of the particles. If you're going from this state to the left, then we are going to increase the number of particles. If you're increasing the number of particles, then you increase the entropy of change, because there is more microstates over here, and therefore the entropy is higher here. So if the reaction is going in this direction, where in which the particles diminish in number, then we can say the change in entropy has been negative or has been diminished. So if you just even look at the equation like this, that the reaction will have a negative or positive delta S based on this one. So you'll notice here there's only one particle because there was only one coefficient of 1 in front of the nitrogen. So technically you have particle N2 and 3 of the H2s to make 2 of the NH3s. So did the number of the particle increase or decrease? So it has decreased. You only have two things, right? Two molecules, where you started off with 4 molecules. Yeah, they might be smaller, but you decreased the 2 number of molecules. So therefore, you can see delta H being negative here because you're putting in more of order rather than disorder. So this will be negative. All right, here it says predict the sign of entropy change for the following processes. Give reason for your prediction. All right, so let's try the first two, and you can try the second two, the third, and the last one. So the first one, we have sodium nitrate, and that's solid forming into 2 aqueous. So here we know that the entropy change probably for this one would be positive. And this is because your phase change, from solid to liquid, dissolved, increases entropy. The second one, the freezing of a liquid water. So you're going from H2O liquid to H2O solid. So what do you think? So you're changing the phase, and because you're going into solid state, more of a stable state, so this would have a change in entropy of negative due to phase changes. Okay, you try for the next two and come back. So here is the key. So this would be, C would be delta S would be positive. That's because there's a phase change from solid to gas. And similar for this one too, there is a phase change, and you can see more of the particle has been made.